All right, so this video is going to focus on another difference of cubes example here. This one with a little bit of a twist to it first though. So let's pretend that we know that we're dealing with difference of cubes. There are 3 specific criteria that you need to know. So just quickly, 2 terms, they have to have different signs and they both have to be perfect cubes. So as long as we know we're dealing with difference of cubes here, first off, you definitely need to have the formula here. I don't know any way really around to do it unless you absolutely know the formula. So here I have the formula written for us on the board. All right, so the formula here has a lot of x's and y's. It says as long as we have an x cubed minus a y cubed, it's going to factor into this binomial followed by this trinomial. So for me, the most important thing is figuring out what is your x, what is your y. Now, your x and your y, those just come from the cube roots of your first and second term there. So x is just what times what times what is going to give you that first term. And then y is what times what is going to give you that second term there. Now, there's a couple of different ways that you can actually look at this problem. I'm going to start with, the first way that I'm going to start with is this. So looking at our first term here, we have y plus z cubed. Now, the only way to get y plus z cubed is y plus z times y plus z times y plus z. So I'm going to say that my x is a y plus z. Y then is going to be what times what is 125. And 5 times 5 times 5 is 125. Now, there's 2 different ways we can do this here. We can plug this x and y into this formula here. There's a couple of people that might recommend doing some substitution here. If we don't want to plug in this y plus z straight from the beginning, we can actually say, hey, x equals y plus z, and then we could input an x into this formula. Though we are going to have to plug the y plus z back in the end anyways, so I'm not sure which one of those would be easiest. I might just go with the y plus z here. So if we have our x is equal to y plus z, y is equal to 5, let's plug that directly into this formula. The first thing we have is the x minus y. So take your x, which is y plus z, and then let's subtract y, so minus 5. Then we have to plug into our trinomial, and the first thing we have to do is say x squared. Now be aware here, our x is y plus z. So if we square that, that means we have y plus z times y plus z. We actually need to multiply this thing out right here. So using FOIL, y times y is y squared. Outside, so y times z is y times z. Inside also gives us y times z. And then last times last is z squared. Make sure that you combine those 2 middle terms. So y squared plus 2yz plus z squared. That's what our x squared term is right there. So let's plug that in. Y squared plus 2yz plus z squared. Now the next thing we have to do is we have to add the x plus the y. So our x is y plus z, and we need to multiply it times y, which is a 5. So we need to say y plus z times 5, which means we need to distribute this. 5 times y is 5y, plus 5 times z is 5z. Plug that in. So plus 5y plus 5z. All right, then the next thing that we have to do here is we have to square our y term. Thankfully, that's probably one of the easiest multiplications we have here. Our y is a 5, so if we take 5 squared, 5 times 5 is 25. Look over this thing here, just because we have a lot of x's and y's going on, make sure we don't have any like terms or anything that can be combined, but I don't see any, so we are done with this example here. So a little bit of a big one just because we had this binomial term here as one of them, but that's okay, it's doable. We should hopefully know how to do that multiplication there. So just be aware every once in a while you will have a little bit of twist on these difference of cubes where you might have a little bit more going on to it.